can also use TArrays as if they were a different type of data structure. So I have a demo struct, which is really just a struct that has two values, an x and y of different types, and a default R constructor, and a constructor that lets you specify the int and the float. We can treat an array like a stack, so I'll create a new array, call it my stack. We can push to the top of the stack and pop from the stack. So if you are not familiar with a stack, it is a simple data structure. Imagine like a waiter carrying a stack of plates. He goes to a table, picks up a plate, sets it on top, and then when he goes to wash them, you can take the top plate off to wash that one first. You're probably familiar with that data structure, and that maybe that's not a great example, but nevertheless, the TArray has functions on it that let you treat it like a stack. So we can push to it, which means push to the end of the array or the top of the stack. So we push one value. You can see we now have one element, push another, and then after that we have another, and push another, and at the end we have another. So the stack is kind of growing down in this case. So we can get the num of the stack by just calling num, and then we can get the top of the stack by saying last. And then we can pop from the stack. So we popped the first one, pop the top, pop again, remove the one from at the end, and then lastly remove the last one, and there you go. You have a stack. Stacker is pretty simple. You wouldn't even really need these functions to emulate it. However, there's another data structure an array can be, which is a heap. And so I'm going to create an array called my heap. It's going to represent a heap. And a heap is a data structure you probably learned about in computer science. They are often used to implement things like priority queue. Let's just see what it looks like. So I'm going to add a bunch of values to our array. So we're treating it as an array. If I look inside of it, the values are in the order I added them. There's a function called heapify. And if I call that, it makes it like a heap. And with these many values, you don't really see much difference. But if you notice, the 5 and the 4 replaced. And so the most highest priority thing in the heap right now is a 1. And so if I do heap pushes, so I want to push 10, 9, 8, 7, 6. I added them in the order of 10, 9, 8, 7, 6. But if we inspect the heap, we'll see that they actually are jumbled. So the highest priority thing is still 1 at the top, but the 10 is actually at index 5. And so if you're familiar with the heap data structure, it's beyond the scope of this video. You could look up how that is calculated, but that is consistent with the heap. So if I call heapify again, it actually is kind of redundant. It's already in the heap form. If we look, we'll see that it's still there. So we can get the top of the heap by asking for HeapTop. And remember, this is just still a TArray. So the HeapTop we can see as 1. So we're, by default, it is acting like a priority queue where the highest priority are lower numbers. And then we can do HeapPopDiscard. And if we inspect the heap, now the 1 is gone and the 2 has taken its spot. And so again, we can get the HeapTop, which is now 2. We can HeapPop, and now the top is 3. So it's going in order as a priority queue. Top of the heap is 3, pop. And so there's also another way to pop. So we have HeapPopDiscard, which gets rid of it. And we just have HeapPop, which allows you to do it as a reference and do it all in one operation instead of 2. So if we look at the heap, the top is 4, our local variable is 3, we call HeapPop, local variable is now 4, top of the heap is now popped 5. You can see things are reordering. So the heap is preserved as we do these heap operations. You can do things like change the way the heap works. So by default, if we look at heapify, so heapify in the array header says it assumes a less than operator, but we can use a predicate and do a greater than operator. And so we have our heap predicate. Now I can heapify with that predicate. If we inspect our values, there's our values. Heapify with that predicate, and now 10 is at the top because it is the highest priority in our priority queue, our heap. And we can do heap pushes and provide the predicate. So if we inspect that, now 77 is at the top because our predicate has changed the way the heap works. We do 13, which we can see in our heap that 13 slots in there. And we can get the top of the heap again, 77. We can discard the top. And you can see that the 77 was removed from the heap. And again, we can get the top of the heap, which is now 13. And so that's how you can make a TArray behave like a heap or stack. Now it's important to note that we are doing buffer resizes, and many of these functions actually allow you to specify that shrinking is false. So if we go to HeapPopDiscard in the array header, you can see that it has a bool allow_shrinking. And so you can reserve your heap. And so you can call reserve initially to reserve your memory up front. And when you do heap pops and things, you can add the argument to specify false for allow_shrinking, and it won't do dynamic resizing, just like regular TArray functions. The other gotcha with this is the heapify functions and HeapPushes assume that a pointer can be dereferenced. So you read this note, if your array contains raw pointers, they will be automatically dereferenced during heapification. So you have to be really careful not to put null pointer into your array if you're using it like a heap.